So today we continue our fraction study with adding and subtracting fractions. For whatever reason, this tends to seem a little bit more difficult for students, so you may try to watch the entire video. Because I also do try to connect it with the kinds of fractions you're used to, non-algebraic, just arithmetic fractions. So you'll see on the notes that I started that I start with an example with just numbers, things that we're used to. And then I move it into algebra, and I do that so that you can see that math is consistent and you can see the thought process behind why we have to do what we do with algebra. So here we go. To add or subtract fractions, you must have common or like denominators. And you know that. You know when you see a problem like 5/3 minus 4/2, my common denominator would be 6. We'll talk about how actually you would have factored later, but these don't factor, they're both prime numbers. So when you can't factor, you include one of each of the factors. So what you technically do in your head that you don't even know you do anymore is you say, oh, I need a 3 is my common denominator, and I need a 2. So really, before I go to the step that I set up earlier, what you do is you include one of each factors in your denominator. And then you look and say, oh, this guy, 3, is missing a 2. So you multiply it by 2. And what you do to the bottom, you have to do to the top. So 5 times 2 is 10. Over that 2 times 3 is 6. Over here, 3 times 2, well, this guy has just the 2, not the 3. So I need to multiply it by 3. What I do to the bottom, I do to the top. 4 times 3 is 12. So this is kind of a little sidestep through the thought process with numbers. Now, once you have a like denominator, you keep it and combine your tops. Again, I'm showing all the little steps. We'd say 10 minus 12, so that you'll understand the process when it comes to algebra and it seems a little trickier. Combine those tops. 10 minus 12 is negative 2 over 6, and then you reduce. Now again, for us, reducing means factoring. So I might rewrite this as negative 2 over 2 times 3. There's the prime factorization of 6. Then you cancel like factors top to bottom, and you're left with negative 1/3. Now, I would never expect you to go through all of this with arithmetic. But again, when you start to feel stuck with the algebra, always go back to something more basic and think about the process. Because again, math is indeed consistent. You've actually already learned everything you need to know. Now we just apply it to tougher circumstances. So let's do that. So with this next example, I have a very similar problem. I have x minus 5 over 3 minus 4 times x plus 1 over 2. Now, it looks all kinds of different because of the variables. Don't worry about that yet. Let's do the same kind of thing. I need a common denominator of 6. So I will skip that little intermediate step from above because they aren't variables, they're still numbers. I need to multiply this bottom by 2 to make a 6. What I do to the bottom, I must do to the top, and remember to distribute. So it's going to be 2x minus 10 over 6. Now with this one I'm missing a 3, so what I do to the bottom, I must do to the top. So this outside is really 12, and I need to multiply that through. And I'm left with 12x plus 12 over 6. Because 3 times 4 is 12. Distribute the whole thing through. Now that you have your common denominator, you keep it. Combine your tops. Be very careful with subtraction. You're subtracting that whole second number. So this is 2x minus 12x, negative 10x, and negative 10 minus negative 10 minus 12 is negative 22. Now again, we wonder if we can reduce that. The best way to find out is to factor what you can. With negative 10 and 22, I can take out a common negative 2, and I'd be left with 5x plus 11. A positive times a negative gives me that negative back right there. And that's all over 6. And now 2 divides into 6 3 times. So my final answer would be negative 5x plus 11 all over 3. Okay, so it sure seems more complicated, but it's very much like the arithmetic. So my next question is, what about a problem like 5/9 minus 1/12? Well, again, I need a common denominator. Neither of the current denominators are prime. So really what you do is you take each denominator and you factor it. 9 is 3 times 3. 12 is 4 times 3, which is 2 times 2 times 3, if you really want to get down to prime factors. So for your common denominator, you need to include each factor, not hurt anyone's feelings. So I need to include 3, but I also need to include this 4, 2 times 2, and this 3, because it's a different factor essentially from that 3. Okay, so my common denominator has a 3, a 3, and a 4 in it. Well, this one only has a 3 and a 3. I need 4 more. I need to multiply by 4. 5 times 4, what you do to the top, you do to the bottom, is 20. Over here, I have this 4, and I have one of the 3's, but I need another 3. What I do to the bottom, I do to the top. So I really have 20 over 36 minus 3 over 36. But you have like denominators, you keep them, combine your tops. 20 minus 3 is 17. You always try to reduce, but 17 is prime, so in this case, you're done. Again, I would never expect that you would factor numbers like that to subtract. I think you could probably look at 9 and 12 and see the common denominator of 36. But when you factor like this, you'll understand why with algebra I say math is consistent, and we need to do the same thing for this problem down below. I have x over x squared minus 4x plus 3 and x over x squared plus 2x minus 3. I need to factor those denominators to see what's common and what I need. So these are both product sums, and they're quick product sums because the leading coefficients are 1. So two numbers that multiply to positive 3 and add to negative 4 are negative 3 and negative 1. On the right side, the two numbers that multiply to negative 3 and add to positive 2 are positive 3 and negative 1. So my factors are x minus 3, x minus 1, x plus 3, and x minus 1. Again, I need to include one of each different factor in my common denominator. So I need to include this x minus 3. I need to include this x minus 1. And I need to include this x plus 3. I don't include x minus 1 because I've already included it down here. I haven't hurt its feelings. So my common denominator for this particular problem is x minus 3 times x minus 1 times x plus 3. Yes, they start to look ugly. Okay, well, I look at this fraction and I see that its denominator is missing x plus 3. So truly I multiplied this, x plus 3. What I do to the bottom, I do to the top. Distribute that through. X squared plus 3x. This fraction is missing the x minus 3 from the common denominator. What I do to the bottom, I do to the top. Multiply it through, and I get x squared minus 3x. Now that you have a like denominator, you keep it. Combine your tops. X squared minus x squared cancels. 3x minus a negative 3x is like 3x plus a positive, so that's 6x. And there's actually no more reducing I can do here. This isn't a binomial, so it doesn't factor or reduce any of the members of that denominator. There's absolutely no reason to multiply that back out. You should note what x cannot be: 3, 1, or negative 3. So plus or minus 3 or 1. And then you're done. That's it. Just try a couple for homework, and we'll do lots in class. Good night.